Hi, this is Mrs. Vrobel. This is part 2 of electrons and atoms. So in the first section we talked about what is light, how do we describe it, we talked about wavelength, frequency. Now we're going to talk about the theory of light and how to do some energy calculations. So there was a physicist by the name of Max Planck, and he came up to a theory that light is essentially a flow of energy. He also determined that light can be best described as energy packets or photons. So whenever you hear the term photon, just assume that we're talking about a packet of energy. And in his theory, he states that light is essentially just pure energy. So like I said before, it has no mass. Okay, now there's actually two different ways that we can describe light. We could describe light as a wave, or we could describe light as a photon. Now when you're looking at light as a wave, we're looking at radiant energy. So we're looking at the light that's coming from the sun, essentially. Photon theory, it explains the same thing. For wave theory, so we're talking about velocity, and we're looking at the speed of light once again. And remember, I told you the speed of light stays the same. The only time it changes is if it goes through a medium. So if it goes through air or if it goes through water, we're talking about a different speed. Now the difference here is, look at how with photons we're actually looking at d over t. So d equals distance, and t equals time. So it's a slightly different calculation. With the wave theory of light, we're looking at color in forms of wavelength. So do you remember which color has the longer wavelength? Hopefully you said red. With photon theory, we're looking at color as energy. So which would be more energetic? Would it be green or would it be blue? Hopefully you told me blue. Okay, when we're looking at wave theory, we're talking about the bending of light. So anytime light comes in contact with the medium, like a prism, it's essentially bent, depending on what that medium is. The problem with the photon theory of light is it doesn't quite explain refraction. How does a photon of light get bent? The problem with the wave theory is there's no way that waves can explain the photoelectric effect. Remember that photons are ejecting electrons from metals, whereas photon theory explains very well the photoelectric effect. Okay, so as I mentioned before, Albert Einstein, one of his other contributions to science besides relativity was that he determined light has to have dual nature. And through this, he essentially described the photoelectric effect by explaining that light behaves like a particle. So when it behaves like a particle, like I said, it comes in contact with the metal and ejects an electron. And then you can take those electrons and create a circuit with it. Please remember that just like light as a wave has no mass, light as a photon has no mass. So it's pure energy. Okay, with de Broglie. So de Broglie is another scientist, and he essentially saw light as having both wave nature and particle nature. So he was very good at actually combining both of them together. And de Broglie, actually, you'll find he'll help explain the behavior of electrons much better because of this equation. So he essentially came up with P equals h over lambda. So h is the Planck's constant, and lambda, do you remember what lambda is? Wavelength. Okay, so wavelength, when divided by Planck's constant, I'm sorry, when Planck's constant is divided by lambda, we essentially get momentum.